Two ships leave the same port. At noon, ship A sails north at 19 miles per hour, and 30 minutes later, ship B sails east at 12 miles per hour. How fast is the distance between them changing at 2 p.m.? So let's say here's the port, and ship A is sailing north at 19 miles per hour, and ship B is sailing east at 12 miles per hour. The question is asking for how fast is this distance between the two ships changing at 2 p.m. Now the key to solving these related rates questions is to come up with a simplified picture. Well, in our case, the picture is already simple enough, so it won't be that different. We just have to draw a right triangle, and ship A's distance covered is this place here, so I'm going to put as X, and ship B's distance covered would be this length here, so I'm going to put it as Y for ship B. Now some of you might want to put this as X and that as Y because, you know, just like the coordinate system. That's fine too. So either way, you'll be able to find the solution. Now because the quantity that we are trying to figure out is this distance AB, we need to assign the letter for that as well, so I'm going to put it as Z. Now when you draw a simplified picture for related rates, make sure that you assign letters for anything that changes and anything that is involved. You never put numbers for these sides unless it's a constant throughout the entire problem. So if ship B was always standing still at some distance from the port, in that case this value could be just replaced by a number. But don't do that if the distances are changing. Okay, so what's given here? First, ship A sails north at 19 miles per hour, so this X will change with respect to time. The rate of the distance with respect to time, that's called the speed. Yeah, that's 19 miles per hour. And the rate of change of this Y, that's the speed of ship B, which is 12. And the question is, how fast is the distance between the two, the Z, changing when, or at is the same thing as when, right? At t equals to 2. That's the question. Now notice that we haven't made use of this 30 yet. We'll be using this much later, as you will see later, okay? This is not yet the complete setup because in order to relate the rates of X and Y to the rate of Z, you need an equation between these quantities. And because this is a right triangle, there's a perfect equation between the values, which is the Pythagorean theorem. See, more likely than not, when you see a right triangle and the related rates, it's the Pythagorean theorem. There are exceptions though, like when you have more than one right triangle, then you might be using ratios of triangles rather than this Pythagorean theorem. But since this does come up often, let's say you have a related rates question and you have no idea how to do it, then just writing the Pythagorean theorem shouldn't hurt, okay? Alright, now let's think about what this dx dt means. Dx dt means you're thinking of x as a function of t. And it's true because as time progresses, this distance x will increase, right? So there's definitely change of x with respect to change of t. And And this is just another symbol for x prime, right? So in order to get an equation for dx dt, you need to differentiate both sides by t. So I'm going to differentiate, and in this context, differentiate means d dx, okay? So just not dx, sorry, d dt. So just keep that in mind. So let's try to do one by one. First, x of t, x is a function of t, nested inside the square function. In that case, when you hear the word nested, what rule must you use? You have to use the chain rule, right? So we have to use the chain rule. You differentiate the outside function. X squared is the outside function, so if you differentiate, that's 2x. But then you pull the inside function. Xt is the inside function. You pull it out and you differentiate. So you pull the x out and differentiate, so that's going to be dx dt. Same thing here. You differentiate as a function of y, so it's 2y, but you pull the inside function, which is y of t, outside, and that's dy dt. And for this one, this is 2z, and pull the z out, and dz dt. Notice how we already know dx dt, we already know dy dt, and you need to figure out what dz dt is. So you're trying to look for dz dt, which means you have to isolate this dz dt. How do you do that? Well, just get rid of the thing in front of it, right? So I'm going to divide both sides by these 2z, and 2z cancels, and because every term in both top and bottom have 2, in that case you can cancel that too. And the result is that you have dz dt equals to x times dx dt, but dx dt is 19, so it's x times 19. And dy dt is 12, so it's y times 12 divided by z. Okay, now we feel like we almost have the answer, right? Not quite, because this is dz dt for any time. We're really looking for dz dt when t is equal to 2. So let's write down our result and think about what that means. dz dt is 19x plus 12y over z, and then we're looking for dz dt when t is equal to 2. Now, you should be convinced that for time t equals to 2, at 2 p.m., there will be some distance between the port and ship A, and another distance from the port to ship B. So these values x and y will be some given value. We can actually figure out that value. And once we know those values, we should also be able to figure out what z is using geometry. So this is not an answer, because in related rates, usually you're looking for the answer as a value, and this is not a value, it's a function of x and y and z. So we have to figure out x, y, and z in order to answer this question. So let's do that. At time t equals to 2, ship A sailed for how long? It started at noon and it's until 2 p.m., so 2 hours passed, right? So ship A sailed for 2 hours, and because distance is time times speed, time is 2 hours and speed is 19, you get 38. On the other hand, ship B sailed for, and now that's when we use this 30 minutes. 30 minutes is half hour, right? Since ship B started 30 minutes after ship A, it traveled for half hour less than A. So ship B only traveled for 1.5 hours instead of 2 hours, right? So in that case, y would be 1.5. So distance y is equal to time 1.5 times the speed, which is 18. Now, let's go back to the picture and see what's going on here. So basically what we have here is this side x is 38, this side y is 18, and we still don't know the value of z, but because this is a right triangle, we know that 38 squared plus 18 squared should be z squared. In other words, z must be square root of 38 squared plus 18 squared. Now, I did this with a calculator, and the calculator gave me this value 42.04476. So let's just write that down, 42.0476. Okay, so we almost have the answer now. X is 38, y is 18, z is 42.0476. Therefore, dz dt at t equals to 2 would be, you plug in all the values that we got. Okay, so it's 19 times 38 plus 12 times 18 divided by 42.0476. Okay, that I'll need to use a calculator for. So let's use the calculator. Right, so let's see. 19 times 38 plus 12 times 18. And then we should take parentheses and divide by 42.0476, and that's 22.31. 22.31. So that's our answer. It's 22.31 miles per hour. Don't forget the units, right? This is the rate of change of distance with respect to time. That means it's miles per hour. It's speed. Okay, so the answer is 22.31.